Welcome to part 9 of our Marine Engineering Multiple Choice Questions video on the freshwater generator. I am Assistant Professor Manivannan S., and I will be guiding you through these questions. Question 1. Which of the following is not a common use of freshwater on board a ship? A. Drinking and cooking. B. Boiler feed water. C. Engine fuel. Or D. Firefighting. The correct answer is C. Engine fuel. Freshwater is used for many purposes, but not as engine fuel, which typically uses diesel or heavy fuel oil. Question 2. Freshwater is essential for which of the following on a ship? A. Cooling systems and sanitation. B. Propulsion by diesel engines. C. Lubricating fuel lines. Or D. Painting the hull. The answer is A. Cooling systems and sanitation. Freshwater is critical for maintaining engine cooling and for sanitation purposes, such as washing and cleaning. Question 3. Which of the following is a common reason for saltwater carryover, also known as priming, in a freshwater generator? A. Low shell water level. B. High shell water level. C. Low evaporation rate. Or D. Reduced feed water contamination. The answer is B. High shell water level. An excessively high water level in the evaporator shell can lead to salt water mixing with the generated vapor, causing priming. Question 4. Priming in a freshwater generator can occur when A. Brine density is too low. B. Brine density is too high. C. Salinity of feed water is low. Or D. Evaporator temperature is high. The correct answer is B. Brine density is too high. High brine density increases the potential for foaming and excessive boiling, which contributes to priming. Question 5. Which of the following can cause loss of vacuum in a freshwater generator? A. Fouled ejector nozzle. B. Defective vacuum breaker. C. Air leakage at joints. Or D. All of the above. The answer is D. All of the above. Any of these issues, a fouled ejector, defective breaker, or air leakage, will lead to a loss of the necessary vacuum for efficient operation. Question 6. What happens if the vacuum reaches 100% in a freshwater generator? A. Salinity decreases. B. Boiling rate decreases. C. Salinity increases due to agitation. Or D. Water becomes safe to drink? The answer is C. Salinity increases due to agitation. An excessively high vacuum can lead to violent boiling and agitation, causing seawater droplets to contaminate the distilled water. Question 7. Which of the following is a method to make fresh water safe for drinking? A. Boiling only. B. Chlorination. UV sterilization. Silver ions. C. High pressure filtration. Or D. Increasing vacuum. The answer is B. Chlorination, UV sterilization, silver ions. These are common methods used to disinfect and purify freshwater, ensuring it is safe for consumption. Question 8. To control excessive vacuum in a freshwater generator, you should A. Shut down the evaporator. B. Open the vacuum breaker to maintain approximately 93% vacuum. C. Increase the brine level. Or D. Increase the salinity. The correct answer is B. Open the vacuum breaker to maintain approximately 93% vacuum. This introduces air to stabilize the vacuum level and prevent excessive boiling. Question 9. What principle does an adductor mainly work on? A. Newton's law. B. Bernoulli's principle. C. Ohm's law. Or D. Hooke's law. The answer is B. Bernoulli's principle. Adductors use the acceleration of a fluid to create a low-pressure area, which enables suction, based on Bernoulli's principle. Question 10. What effect is responsible for suction in an adductor? A. Doppler effect. B. Venturi effect. C. Photoelectric effect. Or D. Hall effect. The correct answer is B. Venturi effect. This effect is a physical manifestation of Bernoulli's principle, where fluid speed increases as pressure decreases in a constricted flow section. Question 11. How does a demister remove liquid droplets? A. By heating. B. By filtration through mesh or veins. C. By chemical reaction. Or D. By evaporation. The answer is B. By filtration through mesh or veins. Demisters work by causing vapor to change direction, collecting larger droplets on the surface of mesh or veins. Question 12. In an adductor, the velocity of fluid increases at A. Diffuser, B. Throat, C. Outlet, or D. Expansion chamber. The correct option is B. Throat. In the narrowest section, or throat, of the adductor, the velocity of the operating fluid increases, leading to the necessary pressure drop. Question 13. What is priming in a freshwater generator? A. Formation of scale inside the shell. B. Carryover of salt water with vapor. C. Increase in vacuum pressure. Or D. Leakage in condenser? The answer is B. Carryover of salt water with vapor. Priming is the undesirable event where seawater is carried into the distillate due to violent boiling or high water level. Question 14. Which of the following is not a cause of priming? A. High brine level inside shell. B. Low evaporation rate. C. High brine density. Or D. Increased evaporation rate? The correct option is B. Low evaporation rate. High brine level, high brine density, and increased evaporation rate are all common causes of priming. Question 15. High water level inside the shell causes priming due to A. Reduced pressure, B. Increased agitation during boiling, C. Cooling effect, or D. Reduced salinity. The answer is B. Increased agitation during boiling. High water levels reduce the vapor space, leading to increased turbulence and agitation that carries saltwater droplets into the vapor. Now for question 16. An increase in the salinity of freshwater may be caused by A. Low brine level, B. Leaking condenser tubes, C. High vacuum, or D. Low evaporation rate. The correct answer is B. Leaking condenser tubes. If the condenser tubes leak, seawater, which is the cooling medium, can mix with the distilled water, increasing salinity. Question 17. Operation near shore can increase salinity due to A. Clean feed water, B. Contaminated feed water, C. High vacuum, or D. Low temperature only? The answer is B. Contaminated feed water. Nearshore operations often involve taking in feed water that is more contaminated with pollutants or has higher than average natural salinity. Question 18. During pressure testing, which valve must be closed? A. Air screw. B. Feed water valve. C. Discharge valve to freshwater tank. Or D. Vacuum breaker. The correct answer is C. Discharge valve to freshwater tank. Closing this valve prevents the test pressure or any contaminants from reaching and damaging the freshwater storage system. Question 19. Which of the following can cause loss of vacuum? A. Proper sealing. B. Ejector pump failure. C. Clean nozzle. Or D. Proper valve operation? The answer is B. Ejector pump failure. The ejector pump is essential for maintaining the vacuum. If it fails, the vacuum will be lost. Question 20. Air leakage in the system results in A. Increase in vacuum, B. Loss of vacuum, C. No change, or D. Increased temperature? The correct answer is B. Loss of vacuum. Air leakage introduces non-condensable gases into the system, which destroys the high vacuum required for the freshwater generator to operate efficiently. Thank you for joining this video. We hope this session on freshwater generator topics has been helpful for your marine engineering studies. We appreciate you watching. Feel free to explore our other educational resources for more content on marine engineering subjects.